All right, guys, this is the first video of section 7.4, and I'm going to cut this one into 3 smaller videos just because we're covering 3 things in this section. We're covering a rhombus and all the properties of a rhombus, a rectangle and all the properties of a rectangle, and a square and all the properties of a square. So I'm just going to cut it into 3 shorter videos rather than putting it all in one longer video. I think that'd be easier. But don't be alarmed when you have 3 because they're not going to be long and brutal. All right, so we're first going to talk about a rhombus. And before we talk about the properties of a rhombus, we need to first talk about the definition. Okay, so the definition, a quadrilateral is a rhombus if and only if it has 4 congruent sides. Okay, all sides are congruent. So I am going to, and I just drew this out on my rhombus that I pasted into my interactive student notebook. You don't have to, but so this side and this side and this side and this side are all equal. All right, so a rhombus has 2 added properties to it, other than it has 4 congruent sides. And the rhombus is generally the shape that people forget the properties the most. So hopefully by having this interactive student notebook available to you on your test, you won't forget it, at least if you do this and fill it out and paste it in. But do know that these are often forgotten about. So the first one is the rhombus diagonals theorem. And the rhombus diagonals theorem tells us that a parallelogram is a rhombus if and only if its diagonals are perpendicular. Okay, and I'm going to put here not congruent. Okay, a lot of people mistakenly say that rhombus has congruent diagonals, and that is not the truth. They are perpendicular. So if you remember, perpendicular means they intersect to form a 90-degree angle. Okay, so to show this on here, I would just put this is a right angle, this is a right angle, this is a right angle, and this is a right angle. All right, and this one, the rhombus opposite angles theorem, I would definitely write a sketch and mark it because the wording of this is kind of confusing and it's a lot easier to visualize it and see a picture. Okay, so the rhombus opposite angles theorem tells us that a parallelogram is a rhombus if and only if its diagonals bisect the vertex angles. Okay, all right, so you're saying what is vertex angles? Well, this is a vertex angle, the angle of the bigger rhombus. This is a vertex angle. This is a vertex angle, and this is a vertex angle. Okay, so when I say the diagonals bisect the vertex angles, that means that this angle here is congruent to this angle here. Okay, and it also means that this angle here is congruent to this angle here. But since the bigger angles, since opposite angles are congruent, all 4 of these smaller angles are also congruent. Okay, and then the same is true for the others. So this and this are congruent. And then here and here are congruent. And since angle ADC and ABC are congruent, all 4 of these angles are also congruent. All right, I want you to go through and try to do A and B on your own, and then we will go over it. All right, guys, so the first thing I did, and you should also, is draw out rhombus QRST, okay? And what you would see is angle Q and angle S are opposite angles. And we know that a rhombus is a parallelogram and therefore has all the properties of a parallelogram. So this would always be true because parallelograms, the opposite angles are always congruent. Okay. Part B, you want Q and R congruent. So are these 2 angles congruent? And this is a sometimes, not usually, but sometimes they can be. Okay. So since a rhombus is a parallelogram, we know consecutive angles, which is Q and R, are always supplementary, okay? So the only time we can have angles be congruent and supplementary is if both are 90 degrees. So if both of these are 90 degrees, it's a true statement. If not, it would not be true. So therefore, the answer would be sometimes. All right, let's look at part A together. It says find the measures of the numbered angles in rhombus ABCD. So I have angle 1, angle 2, angle 3, and angle 4. Okay, well, angle 1 is the easiest because remember, the rhombus diagonals theorem tells us that the diagonals are perpendicular, meaning that this is a right angle. Okay, we didn't even have to do any math to know that. All right, and the rhombus opposite angles theorem tells us that the diagonals bisect opposite angles, which means this angle is congruent to this angle, which is also congruent to this angle, which is also congruent to this angle. And since these big angles and these big angles are the same, half that would be the same. So all 4 of these angles are congruent to each other. So angle 2 would be 61 degrees, and angle 3 would also be 61 degrees. Okay, now angle 4, you have to be a little bit wiser and go about this a different way. Now there's a few different ways you can do it, but I'm going to highlight this triangle right here, and I want you to look at this as a triangle rather than a rhombus. Okay, remember angle 3 is 61 degrees. So if I have a triangle that looks like this, we have a 90-degree angle, we have a 61-degree angle, and I don't know this angle. This is angle 4. Okay, what I do know is that all 3 of these have to equal 180. Okay, so 151 plus x equals 180 minus 151 minus 151. I get x equals 29. So angle 4 is 29 degrees. All right, I want you to try part B on your own, and then we will go over it. All right, so angle ADC, remember we found angle 4 to be 29 degrees, so that means both of these angles are 29 degrees. And ADC would just be 29 plus 29, which is 58. Okay, angle BCD, we know this is 61 degrees, so this has to be 61 degrees. So 61 plus 61 is 122. And if you notice, 58 plus 122 is 180 degrees, and they should be supplementary. 122 plus 58 is 180, so we are good. All right, I want you to try to do example 3 on your own, then we'll go over it. So we want to find the measure of SWT. Okay, so we want to find the measure of this angle here. Now, if you don't know where to start, go back to the rhombus diagonals theorem and read it, and that should help you out. All right, if you go back to the rhombus diagonals theorem, it tells you that the diagonals are perpendicular, meaning that this angle that we need is a right angle, or 90 degrees. So all I would do is I would set this here, 2x plus 8, equal to 90. Then I do a little bit of algebra, and overall I get x equals 41. All right, let's look at example 4, and this is it for the rhombus. So it says if measure of WRV is 5x plus 5, and the measure of WRS is 7x minus 19, find x. All right, for this one, we're going to use the rhombus opposite angles theorem. And the rhombus opposite angles theorem tells us that the diagonals bisect the vertex angles, which tells me this angle is congruent to this angle. Okay, so if these two angles are congruent, that means that these have to be equal. So I can say 7x minus 19 equals 5x plus 5. And now it's algebra, guys. So minus 5x minus 5x, I get 2x minus 19 equals 5, plus 19 on both sides. 2x equals 24. Divide both sides by 2, I get x equals 12. All right, so if you haven't done it already, when you paste the original rhombus page with the definition and the theorems on it, either below it or under it in your interactive student notebook, and a lot of you have already done this, but make sure you write a rhombus is a parallelogram, and therefore it contains all properties of a parallelogram. So in addition to the two properties we just learned, it has all properties of a parallelogram as well.